Hey Steve, how you doing, man?
Hey, great, Yusuf. Good to see you again.
Yeah, as ever. So today we're going to talk about an exciting development for us in Teckel. We're going to talk about IPFS.
Yeah, IPFS, the Interplanetary File System. Most people don't know what that is. So maybe just give a brief summary, use about what that is and how it works and how we got into it.
Oh, right. Wow. Okay. So what it is, it's a file storage system for computers. But the key point about it is, compared with everything else out there, it's decentralized, which means it's not stored on any one set of servers owned by any one entity or corporation. It's distributed across volunteers who put up hardware, install the software on that hardware, and join the decentralized network by doing so. And in that sense, it's resilient because there can be many copies of your data across the world. It can't be tampered with, it can't be deleted because no one controls the decentralized nodes, of course, and it's not under the control of any single entity. So it can't be shut off if someone takes a dislike to you or takes a dislike to what you're saying. But I'd say from our point of view, it's really about the resilience, the fact that it's decentralized, and why we got into it. Well, that goes back 3 years, doesn't it, when we started on the blockchain journey with Ethereum and NFTs, and the IPFS was a great choice for NFTs because one of the things that makes IPFS different to pretty much any other file storage system is the identifiers or the addressing is content derived. So if you put a file up there that says hello world on it, it's not a URL that you define on top of the content. The URL on IPFS, the identifier, is derived uniquely from the content itself. So you have these content identifiers, these CIDs, and they are completely unique to the content within. The content itself is immutable, so once it's been posted onto IPFS, it can't be edited. So for situations where you need that kind of integrity, like NFTs, where you don't want to get rug pulled by your content suddenly disappearing, the IPFS solution is ideal because once you've saved the content there and tagged it appropriately so you can find it again, the content can never be tampered with fundamentally. So that's the background. We built it into Teckle from the beginning for our NFTs, like I said. And then, do we want to talk a little bit more about why we're now revisiting IPFS, Steve? Do you want to give your thoughts on that?
Yeah, but also just to add some clarification about the CIDs. So, use what you're saying is if one little say piece of data or a pixel, if you will, on a JPEG file or anything changes, and you then reload up that file, you actually to IPFS, you actually get a new content identifier as part of that URL, right? So in other words, you can't just replace a file and have the same URL
No,
like you
no.
can with the normal file addressing system, say in the cloud. So normally, say on a website, if you just upload a different file with the same URL, it's obviously a different file, but you can't do that in IPFS, and that's one of its advantages. Like you said, in regards to NFTs, but it doesn't have to be NFTs. It could be any kind of file. If you just want something that's proven original or with a timestamp, or you're trying to prove some sort of provenance, IPFS comes into play in those sorts of situations.
That's right. You can think of it as a hash on the content. So anytime the content changes, that hash identifier changes fundamentally. And that is what we use to retrieve. Now, it's interesting, and I made this mistake. I don't know if you did, Steve, when we first started manipulating IPFS content. I made the mistake in thinking that IPFS was a distributed decentralized storage solution a decentralized file system, but it isn't. It's a decentralized addressing system. And that means that just because you've stored content on IPFS or uploaded it using whatever technique, it doesn't mean that the content is automatically distributed across the world and stored in a decentralized file storage system. Others are working on such things. The problem with that technically is who's going to pay for it? In the end, you've got to put drives, SSDs, in place to store all this information, and it would become a huge problem for someone to just put all this stuff up for free, to make it scalable with the size of the. I mean, there's no limit to the size of file you can put on there, so no one is really going to support all that storage.
Not that. So, oh, sorry, you go on. What were we saying?
The sharing of the addressing is the key thing. So once you have that CID we talked about, that is available to all nodes on the network very quickly. If someone wanted on a node in somewhere across the world to retrieve that file, they very quickly have the CID because that's distributed in the sort of viral network sense. And then when they tap on that to get it, the network finds the node that has that content on it and then moves that content over to the node where it's being requested. Now, that's fine, but the issue really is, well, what about the permanence? Because let's say we have a node or a set of nodes in teckel and we've got some IPFS content on there. It does not stay there forever. IPFS has a garbage collection algorithm, technique that just basically deletes content that's no longer relevant or no longer required, and it's gone forever from our node. So that would be gone forever from the network unless someone else had happened to import it to their node by clicking on the CID or whatever. And that's where we get into the concept of pinning. And pinning is where you can stop that automatic garbage collection. You can say, I want to pin this file or this piece of content on this IPFS node so it is never deleted. And that's where pinning and storage and addressing all come together in the IPFS protocol. Now, in teckel, we also provide pinning. We do it for our NFTs, and now we do it for everything else that we're going to talk about today. But we have to charge for that because it takes up real hardware, real drive space, real servers. But everyone else who offers pinning services also charge for it. It's not, no one is offering free pinning services. That's like giving away free hardware. So that's fine. Hopefully that summarizes what the IPFS network is all about. I think.
Yeah.
Yeah.
Go on, Yusuf. I'm sorry.
Yeah, all I was going to say was, so we started off with IPFS as a decentralized storage addressing solution with immutability and integrity, primarily for blockchain type of projects, NFTs and the like. But then in the last couple of years, we have got heavily into Agentic AI, and we're pushing in many directions on that, and we'll be talking about some exciting upcoming news soon, but we keep that under wraps for now. But one of the things that we noticed with using Agentic AI and using large language models and using generative AI, like everyone else is doing, we get back to that same problem that we had with NFTs. We get back to the fundamental problem that once you've generated content, whether it's with Google's Nano Banana for imagery or whatever, generating videos or audio or images online or text or whatever the content may be, you've still got the problem of where do you store it. Now, of course, you can store it on your local drive, your local device, your phone, and that's fine if you're not building this as part of a product. But of course, we want our product out there, so we want people to be able to generate media content and distribute it and share it with others who they want to give access to. So immediately you're into the same problem that you have with NFTs. You've got the need to store content in a secure, resilient fashion that can be shareable across the Web 3 or Web 2 universe. And so the LLMs generating all this content, they've got nowhere to go with it. Unless, of course, it's on your local drive. And then when it's on your local drive, you've still got the problem of, well, how do I share it? I've now got it on my C drive on Windows or my mounted Linux drive on my Ubuntu machine. Now what do I do with it? Or my phone, it's on my iPhone or my Android phone. Well, now what do I do with it? So IPFS steps in again as being an amazing solution for providing a vehicle for sharing content. Because now, and this is basically the core of what we've built, now when you have generated content with your LLM, you can direct it to the IPFS network and say, hey, I want to store it on there. And then other people can get access to it. Fundamentally, that's what it's about. Now, what we've done is we've built many layers to this IPFS build out. We started off with the NFTs, of course. With the NFTs, we built an API for IPFS that some people were using. But that API, application programming interface, was really designed for developers. It's designed for people to consume machine-to-machine type software libraries. That's fine, and many people can use that through RESTful API requests or webhooks or whatever. But then we developed the MCP layer on top of all of that. So we exposed our IPFS library to the MCP universe, and that allows the LLMs to directly interface with our code without the user having to know the details. So the user can go on to OpenAI or Gemini or Claude and say, send this file to IPFS. And the LLM, through the MCP protocol, will find the appropriate functions and provide all the arguments required to utilize our API to send that file up onto the network, or indeed the other way around to retrieve it. So that's great, and that's something we launched not too long ago, the MCP layer for IPFS, and that works on the teckel app. So if you're generating anything on the teckel app and want to send it to IPFS, you can do so directly, or you can do so using the MCPs. But then the big news, I suppose, is what we released just this week, is the n8n, the n8n build for IPFS. Now, do you want to talk about n8n, Steve, and explain or describe in your view why that's important? And then we can talk about why we built the IPFS library for n8n. And then we can give some very exciting news that we just got in today about that.
Yeah, absolutely. Thanks. That's a great explanation. I do want to add too, also that, unless you're wanting to just store things on your own devices, which is always great, you might as well leverage your own storage space as much as you can. Most people, though, go to the cloud either for backups or for extended amount of storage. And the big cloud operators charge for that space. They rent it out, so to speak, as a monthly fee. And I've done a little cost comparison between IPFS pinning costs and cloud storage costs, and honestly, I found that IPFS is less expensive. Maybe if you are storing huge amounts of data, it becomes more competitive. But IPFS is a great deal to save money on storage costs. And whether you pin with us or pin with other providers, it's something that you might want to look into if this is your first introduction to IPFS. Anyway, getting to n8n, yeah, I've been, Yusuf, as you know, working on a lot of n8n flows lately. And one of the things that I've noticed about n8n is there aren't a lot of storage options in their node offering, either in the community edition or their cloud edition. And so what we found is that really there was sort of a dearth of options, and that was really our motivation to to get this IPFS node built and deployed onto IPFS Community Edition. So anybody out there who's an n8n developer, you can right now go out and download the n8n package, IPFS package from npm, and install it in your Community Edition and immediately start using it. And so it just gives you options instead of having to always store to, say, Google Cloud or Microsoft Azure or AWS or whatever. You now have an opportunity to say, hey, no, I'm going to go ahead and store to IPFS. And so it's an option for you. And the nice thing about it, like Yusuf said, is it's decentralized file system, so that it's immutable, and so that it's a different way of looking about how should I say this? It's a different way of looking at at unique files. It basically proves that once you have that CID, that is a unique CID, and if one little digit or character in that CID changes, that means fundamentally the underlying content is changed. Even if it's not noticeably changed, it's changed. And so it gives you a good test of whether a file's been tampered, whether a file has been altered, whether some secret information has been injected into the file, any sort of issues like that. IPFS is a way to easily determine the integrity of a file, the authenticity of a file, the provenance of a file, and so on and so forth. And so now we're bringing that into automation workflows. There are a lot of different platforms out there that do automation workflows. n8n is just one of them. We happen to like n8n for its Community Edition. So, you can self-host it, which is really great. Obviously we do that. And I don't know if a lot of other companies out there allow that option, that sort of fair code self-hosting option. But there are other companies that do automation workflows, and I'm not privy on about whether they're integrating IPFS or not. But anyway, so now, whether you're a giant corporation or just a hobbyist at home building automation workflows for just to run your house, or you have the opportunity to take advantage of IPFS. And IPFS, I think, it's just like the sort of the Community Edition of n8n. IPFS itself is sort of user driven, and so it's sort of a perfect match as far as the philosophy, kind of a grassroots development philosophy.
You mentioned thank you, Steve. You mentioned an interesting point about secret codes or secret information. One thing that I glossed over that was a very important point that I shouldn't have glossed over, so I'll ungloss it now, is the concept of encryption. IPFS is decentralized. Once your information is out on the IPFS network and people start grabbing the CIDs and pinning them, it's publicly available, completely open. Now you might think that's a disaster. How can I keep my information private? Well, that was one of the motivations behind writing our IPFS library. We realized that to be really useful and practically useful, you need it to be encrypted. The content has to be encrypted so that it's private. It remains secure and private. So within our entire suite of IPFS offerings, including the n8n node set, we provide the ability to encrypt on the fly. So when you're sending some content to IPFS with us, you can select, in n8n, you select the checkbox encrypt on upload, or the slider. And what that means is that we will use your teckel API key and some other information undisclosed to encrypt the content before it goes on to the IPFS network. That means that anyone with the CID can open that file, but all they will see is encrypted content. They'll not be able to decipher it without your private your API key, which you can only get through your teckel app, your teckel account. But then that's a hassle if you have to decrypt everything every time you want to use it, which is why within our universe and our n8n nodes, the decryption or unencryption happens automatically on retrieval. So if you retrieve a file from IPFS in our ecosystem, and if it is encrypted, and if you were the person who encrypted it, it will become decrypted and given to you in its original form. And so you have an end-to-end encryption, storage, distribution, retrieval, decryption, consumption, right there within one mouse click, within one setting on the node, which I think is probably the best thing about what our nodes offer, is just the convenience of doing that. Now you could then ask, well, wait a minute, if you're using API keys to encrypt things, it's not end-to-end encrypted, and it isn't. We have to say that right now. Because the teckel servers have access to the API keys, they need to do that, for example, for billing the use of the service. Those API keys are in principle known to the teckel infrastructure, and so it's not end-to-end encrypted your content. The teckel infrastructure has access to the API keys and therefore in principle can decrypt the data. So what we would say to people, if you're really concerned about the ultimate security and privacy, don't send it up unencrypted through teckel with the encryption option then switched on. Just encrypt the content offline before you even touch the teckel infrastructure. So take your content, your file. A good example would be a PDF file. Add the PIN code, add the password to protect your PDF file offline before you ever push that PDF file anywhere near IPFS. Then you can be sure that unless you've shared that password with anyone, your file is private. It's decentralized and stored across the world, but can't be opened by anyone without that PIN code or that password. So there you have the end-to-end encryption possibility. And also you can doubly encrypt it. You can do that, which I've just said, and you can choose to encrypt it again with teckel. And then that binary content will be encrypted yet again. So really that's belt and braces. There's really no issue ever to worry about data privacy using IPFS. So I think those are the main points. Now I want to share some excellent news that we just got in today with the listeners. So we put these IPFS nodes plus some of our other libraries onto the n8n community network through NPM actually 2 days ago, and then we applied to become a verified node on the n8n cloud system itself. And I'm delighted to say that they approved the IPFS node from teckel within n8n. We just heard from Berlin this morning. And what was remarkable about that from my point of view is we were informed that the approval could take up to 4 weeks, typically many days to 4 weeks. Ours was approved in less than 36 hours. So, and we've been informed today that in the next release cycle of the n8n product globally, the teckel IPFS nodes will be distributed with that core set. So you don't even need to go to NPM and download or install our nodes. They'll be effectively part of n8n in about 2 weeks' time. So I think on that, we should invite people to give it a go and try it out. And let us know through the various channels what they think about it. And we look forward to bringing more n8n nodes, more teckel capability to n8n and the other surfaces as we go forward.
Yeah, absolutely. And I just want to add too that one additional way to kind of review your IPFS content is actually on the teckel app itself. We've got a great sort of carousel display, and it's easy to pin and unpin all your content on the teckel app, and so you can monitor everything easily through the teckel app. So if you know, and teckel app is available on the app stores, Google and Apple. So you can always download it, and that's a free download. Obviously, there are in-app purchases for teckel credits, you know, pay for pinning. But like I mentioned before, I think those costs are very reasonable compared to cloud storage costs.
That's great. Okay, Steve, I think that's us done for IPFS for now. I just wish you an enjoyable balance of your day, as they say over there, and look forward to our next session.
Absolutely, yes. Always a pleasure. Take care.
Cheers. Bye-bye.
Cheers. Bye.